Welcome back to my channel. Hope you are doing extremely well, and this is a very one mass coder this side. So today's question is intersection of two arrays with duplicates, right? The problem is very interesting. The problem says that you have been given two arrays. First array is 1 2 1 3 1, and the second array is 3 1 3 4 1, right? Now intersection means the elements which are common, which are present in array A, which is present in B, both, right? So you can see that one is present here, one is present here, right? So your answer will contain 1 for sure, right? 3 is present here, 3 is present here. So your answer will contain 3 for sure. Now, some of you might say that 1 is present here, 1 is present here. Also, this one is present here. That is, two ones and two ones are present here. So 1 should occur 2 times in the answer array. But the question specifically says that I only want 1 once, right? I only want unique intersections, right? I don't have to write 1 again and again. Similarly, 3 should be written, like 3 has to be written only one time, right? Also, the question says that the order of elements in the answer array, elements in answer array needs to be sorted, needs to be sorted, right? That is 1 3 should be presented as 1 3 only. It should not be presented as 3 1. That is not correct, right? This is correct. I hope the question is clear to you and you are here for the answers now. Okay. So brute force, actually very simple, right? So there are two brute forces here. What will I do in the first brute force? I will make an answer array, which is an empty array right now, right? For each element, that is for 1, traverse all the B, traverse whole of B, and then see if 1 is here. For this one, you will find a 1, include it. For this 2, you will not find a 2, don't include it. For this one, you will find a 1, again, only either this or this, again add. 3, again you found a 3. 1, again you found 1. So this, right? Now you will say this contains duplicate. So remove the duplicates. After removing duplicate, it will look like 1 3, and then sort it to be confirmed. Sorting 1 3, right? This is your answer. So what is actually happening? So this is n elements, this is m elements. For each n you are traversing. So O of nm is a time complexity, right? I don't have to add a pseudocode as well to understand the time complexity, right? This is just a brief. Brute force, this is not acceptable at all, right? Second brute force, which is also very clear, insert them into the map, right? So the map for A would look something like, this is the map for map A, and similarly map B. Map A will look like, it has 1 occurring 3 times, 2 occurring 1 time, and 3 occurring 1 time. And map for B looks like 3 occurring 2 times, 1 occurring 2 times, and another element is 4 occurring 1 time. Right? This is map A, this is map B. Traverse map A. So something like this. For it in A, if B of it dot first, that is this for 1, if it is found in B, then insert it. B of it dot first is not, like, B of it dot first is not equal to 0. Answer dot push back it dot first, right? And after that, sort the answer. Also, it will be already sorted because the map contains the element in the sorted order only. So this will be there because this is present here. This will be there because this is present here. 2 will not be found, hence it is not in the intersection. So 1 comma 3 will be my answer again, right? I don't think there is any problem in understanding this, but the main thing, the optimized approach is what is very interesting, right? So my arrays were 1 2 1 3 1. This is my A. My B is 3 1 3 4 1, right? I need to construct the intersection array, right? Let me write it down. Sorted answer, right? Unique elements in answer, right? I hope this is very clear to you, right? Now, to solve these two, what we were doing, for sorted answer, what we were doing, we were creating an answer. Our actual flow was something like this: answer and then sort, right? Can I do the reverse? That is sort, then answer. That is what I'm trying to say. If I sort A and sort B separately, that is A after sorting would look something like 1, 1, 1, 2, 3. And B after sorting would look like 1, 1, 3, 3, 4. I hope this is clear, right? Can I say that if I take the intersection from these elements, the answer I get will be sorted? Suppose I use the first approach. Suppose I use the first approach, the brute force approach. If I do it now, what will happen? My answer is empty. For one, I will traverse one here. For one, I will traverse one here. For one, I will traverse one here. For two, no. So for three, three here. So if you see, this is already sorted. So to get a solid answer, we can use either this or this. Both are correct. I am saying that I am using this one, right? This is my star. I want to use this one. That is, I will use this A and this B. Okay. Now, what will I do? I will say my answer, which is an empty array, right? I will keep a pointer I here and I will keep a pointer J here, right? Three conditions can occur. AI equal to BI. BJ, sorry. AI less than bj, ai greater than bj. These are the only three conditions which can occur. Condition number 1, condition number 2, condition number 3. If this condition occurs, what does it suggest? That the element is in A as well as in B. It suggests that element is in A as well as in B. So what do we do? Add. So add the element, that is 1 will come here, right? Because we added this element should not be added again because we need only uniques, right? I can increment, so I will come here, j will come here. That is after adding I plus plus, j plus plus. Now ai is less than bj. It is not the case here. So again, second thing, because I need to maintain unique, can I say that 1 was the previous element? If you look at A closely, if you look at this, right? What I'm trying to say, this one has already occurred in A. This one is duplicate for this array. You can see that if I count this A, this one, then these two are duplicates. So what will I say? Up until this I is equal to I minus 1. The element is equal to the previous element. Increment your I. That is, I will come here. The condition still holds. I will come here. Now, the condition not hold because 2 is not equal to 1. Similarly, when j comes here, 1, 1. Increment j, right? J comes here. Okay, 2 and 3. Now tell me, array A is sorted, array B is sorted, and AI is less than BJ. 2 is less than 3, right? Now tell me, if 2 is less than 3, if 2 is less than 3, I need to get the equal elements. I am moving in left to right fashion, right? In left to right fashion, the elements are increasing. Now, if this 2 is less than this 3, then to get an element equivalent, that is, I want a 3 from here, 3 from here, that is, I have to increment I. That means whenever ai is less than bj, I plus plus. Okay, so 3 will come here, I will come here. 3, 3, again add, first condition is being followed, right? J will come here, I will come here, right? As soon as I is out of bounds, it is not possible to get intersection because the array is finished. So how will I get the elements which are equal in both, right? So now by symmetry, when ai is less than bj, I plus plus. When ai is greater than bj, j plus plus. I hope this is clear. My answer array is 1, 3. Now can you see this array is sorted and it only contains unique? How we calculate is sorted? By sorting them previously. That is this one. And how we calculate unique? By incrementing up until I, like ai is equal to a minus 1 I plus plus. This is a while loop, right? So I hope this is working. Now if you see the time complexity, we are only traversing one. So O of n is linear time complexity and space is O of answer. That is, the elements which are equal have to be inserted into the answer. So O of answer is my space. So I hope this is clear to you and we are ready to move to the coding section. So here we are. What will I do? First create your answer array, vector int answer. Now before beginning, before writing the sizes statement, first subscribe to the channel. That should be the second step, right? That should be all your steps. Now after that, int I is 0, j equal to 0, the pointers we are talking about. While I is less than a dot size and j is less than b dot size. That is all, both the pointers are inbound, right? First condition, if AI equal to bj, answer dot, let me take a curly braces, answer dot push back AI, right? You can add that bj also. So I plus plus j plus plus. That is that particular set of pointer have been done. Move ahead, right? Else if AI is less than bj, in that case I plus plus to get equivalency. Else j plus plus, right? Now for uniqueness, so while I is greater than 0 and I less than a dot size and ai equal to ai minus 1, up till then I plus plus. Similarly, while j greater than 0 and j less than b dot size and bj equal to bj minus 1, j plus plus. This loop will create your answer array, so return answer. Let us try to compile and run it. Hope it will work fine. It is producing correct output for the compile and run. Let us see for the submit as well. Okay, there is some error. What is the error? Let me see. Okay, we did not sort the arrays beforehand. So sort a dot begin, a dot end, sort b dot begin, b dot end. Sorry for my mistake, guys. Let us try to submit it now. Okay, it is getting accepted. So thank you for watching. Hope you liked it, and please make sure to like and subscribe to the channel. Thank you. Have a nice day.